It is finally time to bring out Desmos. I have graphed y equals x squared and y equals x squared plus 1. And we're going to compare those two graphs. So what's happened here? Every point has gone up 1. So 1 went up to 2, 4 went up to 5, 9 went up to 10, etc. So what's happened to our parabola as we added 1? It actually just took the entire parabola and just shifted it up. And it kept the exact same shape, but it shifted it up 1 unit. If I add the equation y equals x squared plus 2, we're going to see it just shifted the parabola up 2 from the original, 1 more than the last one. Now I'm going to add y equals x squared plus a, where a is a variable, and I'm going to add a slider for it. That way I can change what number I'm adding to x squared. And as I change the number that I'm adding to x squared, I can see what happens to the graph. So right here, I'll have y equals x squared plus 1, because in this case a is 1. And it is actually right on top of the other graph I'd made, y equals x squared plus 1. But as I shift it, you can see the larger the number I add to y equals x squared, the higher the parabola goes. And if I bring it down, and even if I put it into the negatives, it will just shift my parabola up and down. So, taking a look at these quadratic functions, we can see our parent quadratic function, y equals x squared, and we saw the graphs of these two, and as we made the slider go up and down, we saw things like going way up, going way down. So all of these quadratic functions are going to graph to parabolas that have the exact same shape as y equals x squared. They're not going to be narrower or wider, because that coefficient is 1. But what will change is where that parabola is on the graph. This one will go through 0, 0, but these ones will not. As we said before, it's the x squared term that makes this a quadratic function. However, you will find x terms and constant terms in quadratic functions. We haven't started exploring having x terms yet because they shift the parabola side to side and make it messy. But right now we're just trying to focus on what happens with the x squared terms and the constant terms. What did the constant term do? We just saw that it shifted the parabola up and down without changing the shape. It didn't make it narrower or wider. What about the x squared term? Well, we know it's the x squared term that gives our quadratic function the shape of a parabola. The x squared term gives the graph its parabolic goodness, or its parabola status, because it makes the function quadratic. However, it's actually, as we saw earlier, the coefficient of the x squared term that makes the parabola wide or narrow. And I hate to say it, but every once in a while, negative coefficients of the x squared term, we make a frowny parabola. So, it's the x squared itself, the term that gives the parabola shape, the size of the coefficient that gives it its steepness or its narrowness or its wideness, and it's the positive or negative of the coefficient of the x squared that makes it go up or down, be smiley or frowny. And the constant term just takes whatever shape it's given and then shifts it up or down. One last thing to mention about the shift is where you shifted the parabola up 1, the y-intercept was 1. Where you shift the parabola up 2, the y-intercept is 2. It just so happens that the constant term is also the y-intercept on every quadratic function, no matter what, even with an x term.